Hi everyone, my name is Thomas Kim. Today is November 2nd, 2019. This is my 12th episode about linear algebra and the threading building blocks. In our previous episode, episode 11, I explained C++ standard permutation algorithm. If you haven't watched this video, please double click this link and watch this video because this episode continues from my previous episode, episode 11. From this video, show more, click download source code. Parallel algorithm is very important for future programming. Most algorithm that you can find in your textbook is serial sequential algorithm. If we want to take full advantage of modern computing hardware, we have to implement our algorithm parallel algorithm. Some algorithms such as permutation looks like serial or sequential, but if we carefully study, we can find out parallelism. In this episode, we will create a software like this. This software is built using Microsoft compiler. The number of permutation is 13 factorial, 6,227,000,000 permutations. In case of serial permutation, it takes 18.9 seconds. Using parallel permutation, it takes 4.5 seconds. In this case, extreme permutation, it is much faster, 2.26 seconds. So this parallel algorithm is 4 times faster than serial permutation, and this extreme permutation is 8 times faster than serial algorithm. We can try once again. In this run, serial algorithm took almost the same amount of time. In case of parallel permutation, it takes 3.4 seconds, a little bit faster. In case of extreme, it took 2.25 seconds. So this extreme permutation is 8 times faster than serial permutation, but it requires quite some memory. In case of parallel permutation, it does not take much memory. Serial permutation and parallel permutation takes very small memory, almost the same. But this parallel permutation is 5.5 times faster in case of Microsoft compiler. Using GNU compiler, we learned the same program built using GNU compiler. So GNU compiler took 20 seconds for serial permutation and parallel permutation took 2.8 seconds. It is over 8 times faster. In case of extreme permutation, it is 15.9 times or 16 times faster. My computer has 8 hardware core, 16 hyperthreads. If we try once again, so this is the result. Extreme permutation is almost 16 times faster than serial permutation, but it requires quite some memory. In case of parallel permutation, it does not take more memory than serial permutation, but it's 8.29 times, almost 9 times faster. Now with Clang compiler, this is built using Clang compiler. So Clang compiler is much faster than GNU compiler. In case of serial permutation, almost twice faster than GNU compiler. And in case of parallel permutation, it is still 7.6 times faster than serial permutation. If we run again, parallel permutation is almost 7 or 8 times faster than serial permutation. In this episode, we will implement this algorithm, so it can be a little bit long or lengthy. Please be patient and watch through to the end of this session. If you want to know how to implement such algorithm, how to enumerate permutation, subset construction, or combination, please double click this link. If you watch this series of videos, permutation and combination, you can understand how I implement these permutations and combinations. I explain both mathematical theory behind and C++ implementation. Click this button, Show in folder. We downloaded this file from our previous session. Right-click, Extract all, rename 12 parallel permutations. Double-click, copy, paste, rename PAR Permu. Hit enter, delete this file, copy the folder path, paste it to your working directory. Now start Visual Studio Code. Then you should have this file. Oro nl talk play fun nl void test serial permutation size tn stream serial permutation using std next permutation nl std vector size t index. So I will introduce some template type name element type template type name class allocator type template type name class container type std vector using container type element type allocator type element type. We defined alias template type name element type using cache aligned vector t container type element type TBB cache aligned allocator. I say just aligned vector t. So here instead of std vector aligned vector t std generate n std back inserter index n count equal to 0 mutable return count plus oro ems size t do std next permutation index begin index end. Here using namespace talk play fun output std cout with for std cout ems colon index std and there. Now we will test this function void test serial permutations. I say std permutation copy paste for we say size tn for r n. Now we call this function copy start command prompt dir cd 12 parallel permutations clang std c++ 17 permu.cpp l tbb malloc o c.exe hit enter cls. So this is permutation using std next permutation. it is 24 permutations because it starts with 0, ends with 23, so it is 24 permutations. Void test random permutation size tn size tr 0 if r equals 0 r equals n. Stream random and memory efficient parallelizable algorithm. Auto max permu talk play fun NCR NPR NPR NR stream NPR max permu and there using Permutate the ECL type max permu for auto mth permutate mth less than max permu plus mth auto permu without remainder talk play fun NCR NPR ENUM NR mth build mth permutation of NPR without remainder STD cout with I will set here context pair size t filled with 4. Copy this and paste it here. Also paste it here. std cout mth permu without remainder. Copy this std and there. Please note that we need using statement using namespace talk play fun output. This output file defines this operator. Now we call this random permutation like this n. Now compile once again with the clang compiler CLS. So this is a serial permutation using std next permutation. This is random and memory efficient parallelizable algorithm. The result is the same. Okay? So it generates mth permutation without remainder. I will copy this function once again. Copy, paste, test random permutation with remainder. Now here I will add one more type like this. This is with a remainder. And here remainder. Okay? Then here permu with a remainder std and there. Okay? Now I will copy this function name and paste it here and I will disable it. We build again CLS C. I put R, for example 1, then R, we build again CLS C. Please note that this is 4 P1 permutations. For permutation, we are selecting only the first element. Okay? Then if we select the first element, this element is this 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 element. These are the remainder. These are the remainder. I will explain here. We can say talk, play, fun, NCR, NPR, then EMUM, permutation, N, R, 0. And there, it should be the same type, size T. Now if we run it again, build, CLS, C, sorry, I made a mistake. It should be N. Build again. Okay. From this set with 4 elements, if we select the first element, then this is the remainder. This is the remainder. For example, if we select element 3, then this is the remainder of this set. Now we try once again. We change it to, I will change it 5 elements. We build again, CLS, C. So from a set with 5 elements, we select 2 elements in permutation. 5P2 is 20 permutation. We first select 01, then 02, 03. We select 2 elements. For example, if we select 01, then we have 2, 3, 4. These are 2, 3, 4 remainder. The first 2 elements are the same this set. The remainders are complement of this set. The remainders are complement of this set. We will try one more function. Void test extreme permutation. Size Tn, size Tr, 0. If R equals 0, R equals N. String, best performance, but requires some memory. And there, auto permutations. Talk, play, fun, set, build permutations, N, R. Auto, handle, permu, mth, size T, auto, permu, mutable, using namespace, talk, play, fun, output, std, cout, width, field, width. I will fix typo like this. And here too. And here too. Here too. Now here, we can simply copy this part, paste it here, plus plus, permu. Now here, std, for each permutations, begin, permutations, and handle permu. So we call this function paste n r. I will disable this part. I will just let n. I will make it 3, 1. Build again. CLS. So this serial result and the best performance result, these two algorithms gives identical result. Now here I will copy this part, paste with the remainder. Now I will call this function n r. I will disable it, enable it, disable it to compare. Rebuild CLS. So 0, 1, 2, 0, 1, 2, 1, 0, 2, 2, 0, 1. This result and this result is identical. Test random permutation with the remainder. Copy this function, copy, and paste it here. We will rename this function test parallel random permutation. I will delete this part using mutex t TBB spin mutex t mutex auto bucket talk play fun ncr npr pact. This is factorial n-r auto handle permu mutex n r bucket auto ems. I will copy this, cut, and paste it here. Auto permu talk play fun ncr npr enumeration with remainder n r mth auto sub mth size t do while std next permutation permu begin plus r permu and don't forget semicolon here mutex t scoped lock mutex using namespace talk play fun output std cout with field width std cout mth times bucket plus sub mth colon permu std and there. Don't forget sub m's. It should be incremented. Now we don't need this part. Please note that this is lambda closure TBB parallel for permu t max permu handle permu. Please note that we calculated this max permu at this line. I will copy this function once again. Copy, paste, test parallel permu and we call this function name here N R. We call serial. I will remove the rest. Copy this function. I will disable it. Now in the command prompt again, CLS. This serial algorithm, this is parallel algorithm. In case of parallel algorithm, in case of this parallel algorithm, permutations are out of order. 0, 1, 2, 3, 4, 5. Total 6 permutation. These permutations are enumerated in serial or sequentially. These permutations are enumerated in parallel. The index is out of order. Now scroll up. Extreme permutation with remainder. Copy this function. Copy and paste it here. Parallel. Extreme permutation. Change the name like this using mutex T, TBB, spin mutex, mutex T, mutex. Or we have to fix like this: bucket, talk, play, fun, NCR, NPR, pact, N-R. This is for factorial. Mutex, permutations, N, R, bucket. Modify like this. Also, M. Now we don't need mutable here. Or permutations, M's. Or sub, M's. Size T to std. Next permutation, permu begin plus R permu end. Now copy this part, cut, paste it here, indent a little bit, mutex T, scoped lock, mutex. Here we have to modify like this: m's times bucket plus sub m's, fixed like this, then plus sub m's. Now we turn it to parallel algorithm, TBB, parallel for size T, permu size. Now we fixed like this. Copy this function name, copy, paste it here, and R. Now we disable this part, build again, CLS C. This algorithm also works. 0, 1, 2, 3, 4, 5. Total 6 permutations. This is executed in parallel. These permutations are enumerated in serial. Now scroll up from test parallel random permutation, copy up to this point. Copy and here paste. Now we will change the name benchmark like this. Now we don't need this. I will disable it, and we don't need this part. Ctrl C, Ctrl K. In real code, we can put our operation in this block. Now scroll down, comment out, scroll down, Ctrl C, Ctrl K. Also change its function name, benchmark. Sorry, scroll up once again. comment out, comment out. Here, comment out, comment out. Scroll down, void, benchmark, parallel, algorithm. Also, scroll up, copy this function, copy, Control and paste it here, benchmark, disable it, also Control K, Control C. Now in this function, size tn 13 r 3. The number of permutations n factorial equals talk play fun NCR NPR fact n, and there open linear algebra .hpp. If this file is not open, you can double click and open this file. Include talk play fun chrono random. Now in this file again, Control B, double, serial, parallel, extreme, talk play fun, chrono random, stopwatch, SW, benchmark, STD permutation, N, stream, serial, permutation, elapsed, SW, elapsed, talk play fun, chrono random, seconds, and there, serial, copy this part, paste, put it here, like this. Now copy this part once again, paste. Now benchmark, parallel random, N, R. It should be parallel, paste it here, parallel. Copy once again, paste, benchmark, parallel extreme, NR, extreme. Copy, it should be extreme. Stream, and there, stream, serial, parallel, serial, parallel, and there. Copy, paste, paste. It should be extreme, extreme, parallel, extreme. Now copy this function name, paste it here. Now in the command prompt, don't forget to give optimization switch alphabet O3. This is for optimization. Hit enter. CLS C. So it took 11 seconds. Serial permutation took 11.9 seconds. Parallel permutation 1.7 seconds. Extreme permutation 1.2 seconds. So serial to extreme ratio is 9.6, almost 10 times faster. Sorry, I made a mistake here. I have to fix like this. we will build once again CLS C. So parallel algorithm is 7 times faster than serial algorithm. Extreme algorithm is 9.5, almost 10 times faster than serial algorithm. Now with GNU compiler, G, hit enter, CLS, G. In case of GNU compiler, parallel algorithm is faster than serial algorithm almost 8 times. In case of serial to extreme, the ratio is almost 9 times. Now let's try with the Microsoft compiler. In case of Microsoft compiler slash big O2, hit enter, CLS M. We are enumerating certain factorial permutations. 6,227,000,000 permutations. In case of Microsoft compiler, parallel algorithm is about 4 times faster than serial algorithm. In case of extreme, is 8 times faster than serial. We can run once again. This is our optimization result. So parallel algorithm is 5 times faster than serial algorithm. And in case of extreme, 8 times faster than serial algorithm. By the time you watch this video, you can double click this link and download the complete source code of this episode. Parallel programming is very important. Please subscribe to my YouTube channel. Thank you for watching.